Number 86, I'm going to do with the x and y components. So it's pulling right at 64 newtons. It's pulling up here at 128 newtons, and then it's pulling backwards at 128 newtons. I guess what I'm going to do is everything's pulling left and right. Like this is good, but this is not. This is pulling at an angle. So what I'm going to do is resolve this one into its x and into its y components. So they give me this angle is 30 degrees. So I guess I'll find x and y. So I'll say the cosine of 30 degrees is equal to x over 128. So x will come out to be 128 cosine 30, 110. And I'll say that sine of 30 degrees is equal to y over 128. So y will equal 64. Oh, it's always half. Should have known that. So I know that this is 64, and I know that this is 110. So what I can do is I'm going to redraw this, because I'm going to take this out of my picture, because I've just replaced it. So I've got 128. Then I have the 64 pulling this way. I've got the 110 pulling this way, and then I've got the 64 pulling up. So these are all the forces that are now. I can combine these three. So 110 and 100 is 174, and I'm going to subtract off 128. So I can combine these three forces pretty simply by making one force that pulls this way at 46. And then this is also pulling up at 64. So I can find my net force now. That's my net force. I could use the Pythagorean theorem. I can say 64 squared plus 46 squared is equal to the net force squared. So my net force, 64 squared plus 46 squared, take the square root of it, I get 78.8, or 79 newtons. Now I have to find the angle, so I have to find this angle theta. So I'll use the inverse tangent. So I'll say the tangent, inverse tangent of theta is equal to 64 over 46. So inverse tangent of 64 over 46 is, 54.3, so 54 degrees. So 54 degrees above x-axis. Because it's above the, this is like the positive x-axis, so it's above the x-axis. So, you know, it really should say something like that.